Okay, so you can see we've got a nice little integration rule that will help us only with integrating little linear expressions. So it's got to be 2x plus 1, 3x minus 6, minus 2x plus 4, all to some power. So instead of expanding it like we did in the previous example, we can just add 1 to the power and divide by the power, which is typical, but then we also divide by the coefficient of x, okay? So having a look at all these, we've got all of these are linear expressions, so we can apply it to those, which has got different powers, all right? So the antiderivative of this function here is, function doesn't change, 2x minus 4, add 1 to the power, which is negative 1, divide by the power, and then we also divide by the coefficient of x and plus c. So we've got negative 2 on the bottom, so that's equal to minus a half 2x minus 4 to the power of negative 1 plus some c. So we could possibly write it as negative 1 over 2 times 2x minus 4. Okay? Same thing. B, what do we have to do? It's equal to the antiderivative, 2 minus 3x, add 1 to the power, so that's to the 5 on 2, divide by the new power, but then also divide by the coefficient of x, which is negative 3. Okay, so that's what my derivative is. So let's tidy it up a bit. I'll get 2 minus 3x to the 5 on 2 over, well, 5 on 2 times negative 3 is negative 15 on 2. And that's equal to, let's flip it upside down, 15 outside of 2 minus 3x to the 5 on 2 plus some c. All right, so whether or not that's like that or you put the 15 in the denominator under 2 minus 3x, it's the same thing. C, let's rewrite it initially as the power, so it's 2x minus 3 to the power of a half with respect to x equal to 2x minus 3, add 1 to the power, so that's the 3 on 2, divide by the power, which is 3 on 2, times the coefficient of x, which is 2, plus some c. So I get 2x to the minus 3, sorry, 2x minus 3 to the 3 on 2 over 3 on 2 times 2 is 6 on 2, which is just 3, which typically we might bring that 3 out the front there to the 3 on 2 plus c. Last one, again, rewrite as integral. I might bring the 2 out the front, and that gives me 2x minus 1 to the negative 2 dx, which is equal to 2 times the antiderivative, so 2x minus 1, add 1 to the power, which is negative 1, over negative 1 times coefficient of x, which is 2, plus some c. So we can see there, hopefully, that that 2 and that 2 cancel. So I'm going to have equal to negative 2x minus 1 to the negative 1, typically negative 1 over 2x minus 1 plus c. All right, so that's that nice little rule. That one, I've got to check actually. I'm pretty sure it's on our formula sheet. But it's an important little rule to remember because sometimes that's a real typical exam one sort of question. Okay. All right, so let's have a look at, we spoke a little bit about how we can't actually work out the integral of 1 on x dx because that's that. So if I add 1 to the power, I get x to the negative 1 plus 1 over negative 1 plus 1, which just gives me x to the 0 on 0. which we can't work out, which is 1 on 0. So when we get a 1 on x, or x to the power of minus 1, that means the antiderivative of that function is a log graph, right, or a log function. So the key thing to remember here, I think, is this form here. That form of it there. So if we have an integral where the derivative of the bottom is in the top, well, then we have a log function. All right. So it doesn't matter what it is. Let's get rid of that. So if I've got the integral of x squared over, I'll put that, yeah, the derivative of x cubed is 3x squared. So that antiderivative is just a natural log of the bottom function. Okay, so it doesn't matter as long as the derivative of the bottom is in the top. All right, and for us, it's nearly always of this form here. If we think about the derivative of 2x minus 1, it's 2. So therefore, the antiderivative of that function is the natural log of 2x minus 1 plus some constant c. Now, you'll notice that sometimes we use these absolute value modulus signs. All right. Now, whilst they're not a part of the course anymore, it doesn't become crucial. All it really means is that we take the positive value of whatever goes into the log. So it shouldn't really affect us this year, but it's just something to be aware of, that sometimes we use the mod signs instead of a round bracket. All right. So let's think about B. What is the derivative of the bottom? So I want to write this as the derivative of the bottom is -3. So I want to turn that into a -3 on the top. Okay, so in fact, before I do that, let's get rid of that negative sign. So there's my sum. Now the derivative of the bottom there is -3. So if I make that a negative there, the derivative of the bottom is in the top, so that's good. But if I'm going to add a negative, I need to bring a negative out the front so it's still equal. Okay, because now I can write that as derivative of the bottom is in the top, so I can write derivative of natural log 2 minus 3x plus some constant c. Okay, so it's just all about getting it into that form of f dash of x on f of x. So integral, rewrite x to the half minus, let's split it up. So that's right, x to the half dx minus the integral of 2 over x minus 2 dx. Now again, x to the half is fine. If I integrate that, add 1 to the power and divide. So I get x to the 3 on 2 over 3 on 2 minus, now let's look at this function here. The derivative of the bottom there is 1. So if I bring that 2 out the front and make that a 1 there, we have the same. So now I'm going to get minus 2 times natural log of x minus 2 plus some constant c. All right, so if I tidy up that first term there, divide by 3 on 2 means I flip it upside down and multiply. So I get 2x minus 2 natural log of x minus 2 plus c. All right, so it's just remembering that if you've got a fractional indices, so we've got a fraction there, if the derivative of the bottom function there is in the top, well, we have a log function. All right, little application, again, same sort of thing. Let's try and find the y. So we know that y is equal to the antiderivative of 3 over x minus 2 integrated with respect to x. So again, I'm going to bring that 3 out the front, write that as 1 over x minus 2 dx, because now the derivative of the bottom is in the top. So that's equal to 3 times natural log of x minus 2 plus some constant c. So what we're saying is that y is equal to 3 natural log x minus 2 plus c. We do have an initial condition here somewhere though. What's that? Y is equal to 10 when x is equal to 0. So let's put that in. Y is equal to 10 when x is equal to 0. Actually, there's a good example of what I was saying before. So we get 3 times natural log of 0 minus 2. So if you like, we get c is equal to 10 minus 3 natural log 0 minus 2 is negative 2. Now, if I actually work out natural log of negative 2, it's undefined because the log function isn't defined for a negative value. All right, but these modulus signs here say, well, let's ignore the negative sign, and instead we just work out what 10 minus 3 natural log of 2 is. Okay, so that's what the mod function enables us to do. So now that's my constant. So now I can say y is equal to 3 times natural log of x minus 2 plus 10 minus 3 natural log of 2. Now, if I wanted to, I could group those logs together. It's 3 in bracket natural log of x minus 2 minus natural log of 2 plus 10. And when we subtract logs of the same base, we divide. So there's the final form of it there. Okay, so remember, when we subtract logs, we divide. When we add logs, we multiply. A couple more examples here. Again, find the equations with these initial conditions. So again, we know that f of x will equal the integral of 2x minus x to the half with respect to x. All right, and so if I now anti-differentiate, I'll have f of x is equal to 2x, add 1 to the power, divide by the power, minus x, add 1 to the power, divide by the power, plus some c. So that means f of x will equal x squared minus 2 on 3 x to the 3 on 2 plus c. So what initial condition have we got? At x equal to 4, y is equal to 10, or f of x is 10. So I get 10 is equal to 4 squared minus 2/3 of 4, if you like, to the power of a half, all cubed. That's what 3 on 2 is. So I get 10 is equal to 16 minus 4 to the half is 2, 2 cubed is 8, 2 times 8 over 3 plus c. So what's that going to give me? 10 minus 16 plus 16 on 3 is equal to c. C is equal to 2. So 10 minus 6 is negative 6, which is the same as negative 18 on 3, plus 16 would be negative 2 on 3. So therefore, f of x is equal to x squared minus 2x to the 3 on 2 on 3 minus 2/3. All right, let's have a look at example B. Same thing, we've got the derivative, so we need the actual function. So f of x is equal to the antiderivative of, I'm going to bring 4 out the front, write it as a 1 over 3 minus 2x dx. So I need the derivative of the bottom in the top. So the derivative of the bottom is negative 2. So if I multiply by negative 2 there, and then divide by -2, I've got equality. All right, so that means I'm going to have f of x equals 4 over -2, -2 times natural log of 3 minus 2x plus some constant c. So again, I've got f of 4 equals 8, so that means 8 is equal to -2 times natural log of 3 minus 8 plus some constant c. So 8 plus 2 natural log, again, it says -5, but because we're doing a modulus sign, we can make it +5. That's equal to c. So my function, f of x is equal to, what's it equal to? It's equal to, let's write our constant first, 8 plus 2 natural log of 5 minus 2 natural log of 3 minus 2x. Again, we can write those logs together, 2 out the front, natural log of 5 minus natural log of 3 minus 2x, which is equal to 8 plus 2 natural log, subtract log, so we divide. There's our function f of x. All right. Let's have a look. I think there's one. There is. Let's give ourselves a bit more space. All right. If a curve has a stationary point 1, 2 and a gradient of 4x squared plus k, where k is a constant, find the value of k and the expression for the curve. All right, so first things first, what does this tell us? It's got a stationary point here at 1, 2. So what does that mean? That means f dashed of 1 is equal to 0. Yeah, the stationary point is at 1. And this part of it here, it's got a gradient of 4x squared plus k. So that's telling me that f dashed of x is equal to 4x squared plus k. So let's find k first. So let's use that first bit of information there. F dashed of 1 is equal to 0. So f dashed of 1 is equal to 4 times 1 squared plus k, and that has to equal 0. Therefore, k is equal to -4, isn't it? So there's my derivative. So if f dashed of x is equal to 4x squared minus 4, that means f of x is equal to the antiderivative of that with respect to x. So that means f of x is equal to add 1 to the power, divide by the power, add 1 to the power, plus some constant c. All right. Now we've got initial condition, the stationary point. So we also know from there that at x equal to 1, y is equal to 2. So we know that 2 is equal to at x equal to 1. C. So we get 2. Well, let's make them all thirds, eh? So what do we get? We get 6 on 3 minus 4 on 3 plus 12 on 3 is equal to C. So what's that? 14 on 3. 6 minus 4 is 2 plus 12, 14 on 3. So therefore, f of x is equal to 4x cubed on 3 minus 4x plus 14 on 3. All right, off you go.